The most important tool for engineers is a calculator. Without it, you'll find yourself spending tedious hours computing things by hand that can be done instantaneously. But for the last few decades, engineers have had access to something even more powerful than a traditional calculator: computational software. The most recognizable name in the computational software industry is MATLAB, developed by the company MathWorks since 1984. MATLAB is widely used in both academia and industry because of its wide range of capabilities, from simple arithmetic functions to machine learning, and really everything in between is covered. If you have any exposure to a formal engineering education whatsoever, you'll most likely have been exposed to MATLAB at some point. Now, one of the goals of this particular YouTube channel is to make engineering accessible to anyone. The biggest downside to MATLAB for budding engineers is the cost. A lifetime purchase of the software costs $2,150 in 2019 when this video is filmed, though it's only $49 if you're a student enrolled at a recognized academic institution. Moreover, a lot of academic institutions pay for your MATLAB anyway. So for those of you who can't afford a formal engineering education, are still in high school and want to get a head start, or are just out of college or maybe have been out of college for a while and still want to use affordable computational software, fear not. There's an open source variant of MATLAB called GNU Octave, designed specifically to mimic MATLAB in terms of layout and coding. In fact, GNU Octave is such an accurate duplicate, you could take your exact code from Octave, open it in MATLAB, and run the code. This means whatever experience you have in MATLAB will carry over to Octave, and learning Octave will also help you if and when you decide to purchase MATLAB. I should mention there are other computational software alternatives to MATLAB and Octave, primarily Scilab, but because Octave mimics MATLAB so faithfully, I've found it to be the most useful. If you want to work with other engineers, for example, you want to be working with the same software tools. If everyone has been trained in MATLAB, you don't want to be the one person on the team who works with a totally different software. Before going any further, I want to caution you, while Octave is a fantastic recreation of MATLAB, it suffers the same flaws all other free software suffer, and that is that it's free. That means the team working on it does it as a hobby more than as a job, and as such, customer service will be nowhere near as good as what MathWorks provides. You may also run into glitches in the GNU Octave code that could take much longer to fix than if you were to find a flaw in the MATLAB software. That being said, I'll be using Octave quite a bit on this channel, so for the rest of this video I'm going to show you how to download Octave onto your Windows computer and the basics of how to use it. Alright, first search for GNU Octave Windows Download in Google. Click on this download gnu.org link right here, and then you want to navigate over to the Windows section. Now, if you have a Windows 64, which most of you should have, that's a 64-bit computer, versus a Windows 32, that's a 32-bit computer, you want to click on the corresponding .exe file. So in my case, I'm going to click on this installer.exe file under Windows 64. And then you'll see that this downloads to your computer, and it's kind of a large file, so I'm going to skip ahead, but once this downloads, we'll go over to the Downloads window. Alright, so the download is done here. I can just go ahead and click on this because I'm in Chrome, and that will pop open a new window. Okay, so here we are. This is the GNU Octave setup. We're going to step through this just like any other software. We can go ahead and accept all of these. We can go ahead and accept this BLAS library. The destination folder is pretty standard for me. I have enough space on the C drive. You can see that it's going to require 1.5 gigabytes, which means if you don't have enough space on your C drive, you'll either have to make space or move this download to another hard drive. And then this will download. I'll come back once this is done. Okay, now the extraction has completed. I'll go ahead and close this window in the background, and we can go ahead and hit finish. Alright, so at that point, the software is downloaded. Alright, so now that Octave's open, I'll go through a very brief explanation of how it works. If you want more videos explaining how to use Octave, just standalone scripting videos, let me know in the comments below and I'll go ahead and make those. But for now, I'll just explain this quickly. The command window down here is kind of like your basic calculator. This is where you can do things like 2 plus 2. If you hit enter, it gives you the answer as 4. You can do 2 to the 5th power. You can do all sorts of things here. You can create windows. So I'm going to do some commands here you might not be familiar with, but you can say A goes from 0 to 10, and I'll put 1,000 points in, and then b equals a to the 5th power. And then I can plot that, and I can do all of this down here in the command window. When I plot that, it looks like this. So this is the plot of b, which is the y-axis, versus a, which is the x-axis. But I can also go up here into this editor, and the editor lets you create scripts. This is where a lot of the power comes in with computational software, because you can create a script and save it and then reuse it later. So again, a lot of the syntax I'm not going to explain as I go through it, but if you want, I can create a video on this in the future. So I could say that my name is Peter Weigel, the date is November 13th, 2019, and this is a test file. So in this, or we'll call it test script. So in this case, I can do the exact same thing that I did before. I can say that a equals linspace 0, 10. This just linearly spaces the variables between 0 and 10. And then I can say that b is a to the 5th power. And then I can go down here and plot. And I can plot a comma b, and we can make this look kind of nice. We'll add in some parameters here. And then we can say the x label is a, and y label is b. And then we can go ahead and run this by clicking this button up here. It'll ask us to save, so we can go into our example scripts file and say test1. Add directory to load path. And voila, we have the exact same figure as before. The difference is now we did it all in one file, so we can go and store this file somewhere and come back and use it. You can probably imagine the kind of great things you can do with exactly this kind of technology. That's it for this video. Thanks for watching. As always, if you liked the video, make sure to let us know by hitting the thumbs up below. Subscribe to get notifications of new videos and other great content. If you'd like me to do tutorial videos on how to use Octave for engineering applications, go ahead and say so in the comments. Remember, if you're looking for a way to ace your engineering classes, or you just need some help managing your time in school, check out our online courses and tools at figbyfig.com. I'll catch you in the next video.